Assalamu alaikum. My name is Arsalan Farrukh and I teach math and physics. So guys, in this particular video, I will continue on with the concepts of trigonometry and discuss how to sketch the trigonometric graphs. To be able to identify how to sketch trigonometric graphs, you have to sort of identify or learn few specific shapes of trigonometric graphs. Like you have to identify that the graph of sine x for the interval 0 to 360 degrees looks like this. Even if in an exam you are like forgetting how the graph looks like, you can take values at regular intervals of 90 degrees and you put it in the calculator. So you will see that sine of 0 is 0, sine of 90 is 1, sine of 180 is again 0, sine of 270 is -1, and sine of 360 is again 0. So that way you can sort of recall how the graph of sine x looks like. Eventually, it's going to be really good if you can somehow memorize this shape of the graph for an interval of 360 degrees. This is how the graph looks like, and this is a periodic graph which repeats itself after every 360 degrees. And that's why we say that the period of this graph is 360 degrees. And similarly, the graph actually continues on towards the negative axis as well. And you can also identify that how the one cycle of this sine function would look like on the negative axis. And then obviously you can sort of identify that it's just going to continue this way again and again, since it is a periodic function. Similarly, if you can learn or identify the graph of cos x for an interval of 360 degrees, which is also its one cycle. So even if you are like sort of forgetting it, you can just recall it by substituting cos of 0, which will come out to be 1, then cos of 90 would be 0, cos of 180 would be -1, cos of 270 would be 0 again, and cos of 360 would be 1. And this shape of the graph would continue on the left hand side as well on the negative axis. So this is one cycle on the positive axis. This is one cycle on the negative axis. If you can learn it, that would be really good, especially in sketching very difficult graphs. Similarly, this is the one cycle of sine x graph for positive axis or positive values of x, and this is for the negative values of x. And once you would identify or learn how the graphs of cos x and how the graph of sine x would look like, you can automatically figure out the graph of negative sine x, because that will be just the reflection along the x-axis. So for negative sine x, it's going to look like this on the positive side and this on the negative side. Similarly, negative cos graph would look like this on the positive cycle and would look like this towards the negative axis. So these are like the four graphs for one positive cycle and for one negative cycle. You really need to somehow either figure it out in exam or maybe learn it so that you can easily sketch more complicated graphs. Similarly, if you can identify or recognize the graph of tan x as well, in which if you put tan of 0, you will get 0, and once you put tan of 90, you will get infinity. Infinity is a very large value that cannot be plotted on the y-axis, and we represent that by an asymptote, a vertical asymptote. So that means the graph would become a very, very large, increasingly large. So it just tends to get closer to this line, but it never touches this line, because for 90, the value is extremely high. The same thing happens for 270. You can also link it with the idea that 0 to 90 is first quadrant and you have tan being positive, 90 to 180 is second quadrant and tan is negative, then 180 to 270, again, it's third quadrant and tan is positive. One more thing I would want you to notice here is that this particular graph has a different cycle. It repeats after every 180 degrees. So if you look at 180 degrees, then it will start repeating itself again. So the period of this graph is going to be 180 degrees, and this is going to be one cycle of tan x. One more thing that you can sort of identify, because Here the largest value is 1. Here the largest value is not 1. The largest value is infinity. But the value that's between the largest value and the 0 value is going to be 1 in this case. So it's like if at 0 you have tan being 0, at 90 the value of tan is infinity, so at 45 the value of tan is going to be 1. So it's 1 here. Again, between asymptote and 0, this is going to be -1 because it's on the negative side of y-axis. Again, this is going to be 1 and so on and so forth. So if you can identify one point as 0, one point as 1 right in the middle, and the other point as infinity, you can easily sketch this graph. But as I said, I mean, if you look at these 6 graphs, a sine and a negative sine, a cos and a negative cos, a tan and a negative tan. You really need to know all of these graphs for one positive cycle and one negative cycle so that you can sketch graphs in different situations. Now, you can have some sort of transformations of these graphs as well. Like, for example, you have to sketch a graph of y is equal to a sine bx plus c. So if you get a function in this particular form, I would want you to recognize that this c is a horizontal line and the graph is plotted about that particular line. So this is like a sort of a central line and the graph is going to be about that. And this bay actually helps you to identify the period. Like if it's a simple sine x, we know that the period is going to be 360 degrees and it's going to repeat after every 360 degrees. But if it is some other coefficient over here, then the period changes. And you can identify period by using this formula 360 upon b for sine and cos. So if it is sine 2x, then the period is going to be 360 upon 2, and that simplifies to 180. If it's going to be 3x, then the period is going to be 360 divided by 3, so that means one cycle would be of 120 degrees. Similarly, if you have a sine half x, so that means that the period is going to be 360 divided by half, and that simplifies to 720. So that means one cycle will end at 720 degrees. So that's how you can determine the period. And then you can also identify that in a given interval that you have to sketch a graph for, how many cycles are there. So whatever interval you have, you can identify interval over period, and that will give you the number of cycles you have. And one more thing that you have to identify, previously we said that this is going to be 1 because the coefficient was 1, but this basically, whatever number over here you have, is the amplitude of this graph or the maximum value from the central line. So this is going to be the a. So if you have 2 sine functions, so this means this distance is going to be 2 up and 2 down from the central line. If it was 3, then that means it's going to be 3 up and 3 down from the central line, and hence you can keep on sketching the graph. So this is where a is positive, and if it's a sine graph but with a negative a, then it's going to be just the reflection of that. Similarly, this is the graph of cos x. Again, c would be its central line, a would be its amplitude, and b will help you determine its period and hence the number of cycles that you have to draw. And if this is cos, the exact reflection of that along the central line is going to be the negative cos graph. Similarly, if you have like a tan bx plus c, again c is going to be your central line, and the period in this case is not going to be 360 upon b, it's going to be 180 upon b. Because for a normal tan graph, the period is 180. So you can find out this interval by dividing 180 by b. So if it is tan 2x, 180 divided by 2, 90 means this is going to be 90 degrees. And if it is tan 3x, so you do 180 divided by 3, and that means that one cycle will finish at 60 degrees. That's how you can identify the period. And one more thing, C is being the central line and B helps us to identify the period of the graph. A is again, if you look at this point and you look at this point where it approaches infinity, halfway between this, the distance from the central line is going to be A, up or down. So if it's 2 tan, So that means this distance is going to be 2. So it's going to be 2 up from the central line halfway to infinity, and this is going to be 2 down from the central line halfway as it goes all the way to infinity. So if you have to sketch graph, if you're able to identify this point, and an asymptote, that should do for you. To be able to understand how to sketch graphs completely, let's take a look at few examples. Like let's say if I have to sketch a graph of y is equal to 5 sine x minus 2, and I have to sketch it for an interval of 0 to 360 degrees. So I know that the period of this graph is going to be 360 divided by coefficient of x, which is 1 in this case, so that's going to be 360. And if I have to sketch this graph from 0 to 360 degrees, so that means there's going to be only one cycle. So I have to sketch one cycle up to 360 degrees. Minus 2 would be its central line. So what I'm going to do is that I'm going to draw a line at minus 2, and I know that I have to sketch a graph about this line. And then its amplitude is 5. So from minus 2, I know that the maximum value is going to go 5 up, and from the central value it's going to go 5 down. And then I will just make one cycle with the amplitude of 5. So this is going to be one cycle. I have to remember that how the graph of sine x looks like. It's a positive coefficient. This is the shape of the sine x. It's going to be one cycle till 360 degrees about the line minus 2 with an amplitude of 5. And that's how I will be able to get the sketch of this graph. Similarly, let's say I have to sketch a graph of y is equals to 4 sine x minus 1. But in this case, I'm going to have to sketch this graph from negative 360 degrees to 180 degrees. So when I will try and sketch this particular graph, the first thing that I should be able to recognize is that this graph is sketched about y is equal to minus 1. So I will draw a central line at y is equal to minus 1. It's a sine x graph, and if the coefficient of x is 1, so that means its period is going to be 360 upon 1, which will be 360 degrees. So I will sketch this graph in two parts. The positive cycle is going to be 0 to 180, and the negative cycle is going to be negative 360 to 0. So if I look at the positive part of the cycle, that's 0 to 180, that is only 1/2 of a cycle, which is, if we can say that period is equal to 1, that is, if we say that period is equal to 360 degrees, so for 180 degree interval, the number of cycles are going to be 180 by 360 degrees, and that comes out to be 0.5. So that means on the positive side, I'm going to have to just make half a cycle, and similarly on the negative side, I have an interval of 360 degrees. So for 360 degrees, I'm going to have one cycle. So I just continued this on and made one cycle on the negative side. Moving on with example, like let's say if I have to sketch a graph of sine 2x minus 1 for 0 to 360 degrees. Now, the period is going to be 360 upon 2, and that's going to be 180 degrees. So I know that for this particular graph, the period is 180 degrees. I have to sketch it till 360 degrees. So the number of cycles are going to be 360 divided by 180, and that simplifies as 2. So I know I'm going to have to make two cycles. The central line is minus 1, so I made a central line at minus 1. Make sure that this is a dashed line and not a solid line, because this is not part of your graph. So once you have made a central line at minus 1, you have to sketch a graph of an amplitude 1. So it goes 1 up and 1 down, and you have to make two cycles. So we just made two cycles with an amplitude 1. This is one cycle finishing at period of 180 degrees, and this is second cycle finishing at 360 degrees. Similarly, if let's say I have to sketch a graph of 4 sine 3x plus 2, and again it's 0 to 360 degrees, then period would be 360 divided by 3. 360 divided by 3 simplifies to 120 degrees, so that means this graph will have a period of 120 degrees. And if I want to identify a number of cycles, so I will do interval divided by the period, and that comes out to be 3. By looking at these two examples, one might probably feel that why am I doing all of this long working, and why can't I just simply identify that 2x means 2 cycles and 3x means 3 cycles? No, that is not the case always. It is happening only because I'm sketching a graph till 360 degrees. If the interval was different, we will see that later on, but we will have different number of cycles. Similarly, if I would look at this graph of 3 plus 4 cos 2x, which has a central line at 3, amplitude of 4, and since I have to draw it to 360 degrees, so it will have 2 cycles. So I make a sketch of 2 above the central line whose amplitude is going to be equal to 4. So this is 4 above the central line and this is 4 down the central line. How do I know that this is a graph not like this and a graph like this? Because it is a cos function. A shorter way of learning that is that at 0 degrees, cos starts with the highest possible value and sine starts with the central line. That's like one way to sort of memorize this. Now let's look at another example. I have to sketch a graph of 2 sine 3x, but here I'm taking an interval from 0 to 180 degrees. So period is 360 divided by 3, that's 120 degrees. But in this length of interval, if I do 180 divided by 120, I get 1.5 cycles. So the cycles are not going to be 3, the cycles are going to be 1.5, and this is a sine function. So my central line is 0, and I just draw 1.5 cycle in 180 degrees. And then I can simply identify that this should be 60 and this should be 120. So if I label more values, it's going to be better on the x-axis. Let's take another example where I have to sketch a graph of y is equal to 4 cos 2x minus 1. But this time around, I have to sketch it for an interval of 0 to 540 degrees. Period is 360 upon 2. 2 is the coefficient of x. Period is coming out to be 180. I have to sketch it for an interval of 540 degrees. So if I do 540 divided by 180, I get 3 cycles. So that means I have to sketch a graph of cos, 3 cycles of it, about the line minus 1 with an amplitude 4. So I go 4 up from the central line and 4 down from the central line. This is my 1 cycle, this is my 2 cycle, and this is 3 cycles, which are going to be ending at 540. So I can easily identify 540 divided by 3 would be 180, and 180 into 2 would be 360. So hence I can label more values here. Similarly, if I have to sketch a graph of y is equals to 5 plus 3 sine 2x for an interval of 0 to 720, 2x tells me that the period is 180 degrees, and 720 divided by 180 tells me that I have to sketch 4 cycles. 4 cycles of sine function positive with central line at 5. So I have drawn a central line of 5 over here. This line should have been dashed, and the amplitude is 3. So I will make a sine graph 3 above the central line, which is 5 plus 3, 8, and 3 below the central line, which is 5 minus 3, that is going to be equal to 2. This is where 1 cycle ends, and I have to make 4 cycles. So this is 2 cycles, this is 3 cycles, and this is 4 cycles. Since it is a sine function, so it started from the central line. And this is how I will be able to sketch these graphs. Guys, I hope this was a good learning experience for you. If you enjoyed this video, if you had a learning experience, I would really appreciate if you would subscribe to the channel. Thank you so much.